Hello everyone, thank you for joining today's session. It's a pleasure to have you all here for this exciting webinar. Before we delve into the session, let me quickly give an intro about myself. I'm Swati. I'm an AWS certified senior QA engineer with 9 years of experience in the IT industry, specialized in ETL testing. Throughout my career, I have had the privilege of working across multiple domains, including mortgage, trade, insurance, e-commerce, and healthcare in both development and testing capacities. I have been working with Millennium for about 4 years now. On a personal note, I'm a proud mom for a 6-year-old, originally from India, and I'm currently advancing my career in Malaysia's growing tech sphere. I'm also passionate about contributing to the testing community. I'm a mentor at the Mentoring Club and KL chapter lead for Test Tribe, and I have been fortunate to receive recognition through awards like Sign Up Supervoice and Lambda Test's Best Testing Team. Whether you are new to ETL testing or already have experience, you will find valuable takeaways that you can apply to your own work. During the webinar, a Q&A chat box will be available for you to leave your questions at any time. We'll answer them at the end of this webinar. We really want you to hear from you, so you are very welcome to do so. Please note that this webinar is being recorded and will be shared with all registrants in the next few days. Allow me to walk you through the agenda and give you a preview of what's in store for you today. What is ETL? As all everyone know, ETL stands for extract, transform, and load, and how it's a crucial process in data management. I'll walk you through each of these stages where I'll help you to understand how they work together to make data more accessible and meaningful. We'll be exploring how to harness the power of ETL testing in the cloud, where I'll also touch on the tools and techniques used in cloud-based ETL testing to ensure data integrity and efficiency, followed by how cloud services can be effectively used with a sample case study, including a demo. Throughout this webinar, I encourage you to stay engaged and interactive. If you have any doubts or questions, please feel free to jot them down as we go along. At the end of the session, we'll have a Q&A segment where I'll address all of your queries. Your participation is the key, so please don't hesitate to ask questions and share your thoughts. Without any further delay, let's jump in right away. So, what is ETL? ETL basically stands for extract, transform, and load. And the first step is extract. This is the first step, where data is gathered from various source systems such as CRM, customer relationship management, like it has the file format of JSON type, and ERP, enterprise resource planning, where it has the file format of XML, and LOB is line of business, it has the file format of XLS. So this basic task is to collect and import data from various sources into a centralized repository like data lake or data warehouse for further processing. Some basic processing might occur to standardize the format so that it can be easily stored. Data might be ingested in batch mode, like with regular intervals, like periodically, daily or weekly, or real-time mode, like continuous mode. So the raw data is collected and moved to a staging layer. It's an optional layer, so where you can do a basic validation and filtering, kind of filtering the corrupted records and cleaning the records. That kind of operations takes place in the staging layer. It's an optional layer. The next layer is the transformation layer. In this stage, the extracted data is processed and transformed into a suitable format for analysis. This may involve cleaning the data also, filtering, aggregating, or converting into a consistent expected format. Here, the business rules and transformation logics are applied, such as data cleansing, like removing duplicates, handling missing values, and correcting errors. Data transformation, like converting data into a consistent format of enrichment and performing calculations. What is enrichment? Like merging the data from different sources by adding calculations or business logic to get the expected derived data. And data validation also happens here to ensure that the data meets the business rules and standards. Data masking may also takes place here, like anonymizing the sensitive data in case of privacy concerns or compliance issues like that. Then the last layer is the loading layer. The transformed data is then loaded into a destination system, usually a data warehouse, database, or data lake, where it can be accessed for analysis, reporting, or further processing. Loading into data storage. The clean and transformed data is stored in a structured or unstructured format. And also here the data load takes place either in the batch level loading or real time loading, like how it happens in the ingestion layer. So the data can be loaded in large chunks, or it depends on the system requirements. And what is happens in the data warehouse layer? Like data in the warehouse is often organized into a dimensional models such as star schema or snowflake schema. When you want to be in a structured format, you will go for the dimensional models by organizing into fact and dimensional tables to optimize complex queries and analysis for business users. Data from different source systems like CRM, ERP is integrated and stored in a unified format. Also, historical data storage takes place here, where here it is to store historical data over longer periods. It allows business to analyze trends, perform time-based comparisons to improve the performance of the business. Also, data archiving is kind of a historical data storage, like where it stores the non-critical or important data like day-to-day operations for longer-term analytics. So it takes place in the data warehouse layer. It also supports OLAP, online analytical processing, which enables complex queries and data aggregation for reporting and business intelligence tools. The data is structured and indexed to allow for fast querying, aggregation, and reporting. Also, it provides that data security to to the data warehouse layer, where here you can implement proper access control mechanism to ensure that only authorized user can view or manipulate the data. So this is another advantage for the data warehouse layer, and it is a foundation for business intelligence tools such as dashboards, reports, or analytic applications. So it is typically structured to meet the needs of business analysts and decision makers, making it easy to generate reports or perform ad hoc analysis and identify the key trends. The additional layers I have already mentioned is staging layer. The another layer is the presentation layer. In some architecture, after the data is loaded into the data warehouse, it have a presentation layer where the data is optimized for reporting and for end users, like using API endpoints through layers like Elasticsearch. Right. This is about what is ETL. Move to the next slide is ETL testing challenges. Of course, it is a critical process in ensuring that the data flows smoothly from source system to the target data warehouse, ensuring accuracy, completeness, and consistency. However, there are several challenges faced during ETL testing due to the complexity of the data extraction, transformation, and loading process. The key challenges are mentioned here, like multi-layer validation transactions. So it is like due to the complexity and the scale of data involved. So testing the entire ETL pipeline from source to target can be difficult due to the large number of steps involved and the interconnectedness of the different systems. To ensure the entire data flow from extraction to loading into the data warehouse is like seamlessly complex and resource intensive. So how we can solve it? By breaking down the process into smaller test cases and conducting integration tests and focus on validating each step thoroughly. How you can do this? By implementing end-to-end automation testing wherever possible. So what is the problem we are facing here? The lack of automation. Without automation, the manual intervention is required at every step of ETL testing process, leading to the human errors, longer testing cycles, and increased time to detect issues. So the inability to quickly adjust the resources for peak demand can cause delays in processing and testing, and underutilized resources can lead to the inefficient cost management. So these all happens in the on-prem. So cloud services provide the robust automation tools like continuous integration and the CI/CD pipelines, as well as the automated scaling and monitoring tools. So this will help to overcome the lack of automation. The next challenge is partners don't understand the format. Yes, it's challenging to test all the data for correctness and completeness, especially when dealing with the multiple sources and various data format. So the solution is like the data sampling techniques, testing the only that sample data or partitioned testing, and use of automated ETL testing tools to handle the entire large data sets efficiently. So the upfront cost for on-prem solutions are high, and they require ongoing maintenance and upgrades, increasing overall project cost. So in this scenario, you can implement the automated ETL testing tools. Source system changes. Of course, when there is a change in the source system, like the data format is changed or the structure is changed, can disrupt the ETL process and require immediate updates to the transformation rules and the testing procedures. So any change in the source data might lead to incorrect data transformation and loading and affecting the entire ETL pipeline. So how we can solve it? By automating the detection of source system changes and their impact on the ETL pipeline. Also, due to data load failures, due to issues like network failures or database connection problems or constraint violations, the data load failures can happen. So if the data is not loaded correctly into the target system, it may cause data loss or delays in reporting. So if, in the event of such cases, restoring the lost data or recovering from the backup could take longer time, affecting the business continuity of ETL process and testing workflows. How we can solve it? by monitoring the loading process carefully and implement the proper error handling and retries and alerts to detect the failures early. In this way, we can ensure that the data is loaded incrementally and in batches to minimize the issues. So in this way, we can overcome the second challenge. The third challenge is like validating complex and hierarchical data. Yes, there are complex transformations and it is often complex in the ETL process like data mapping, aggregation, lookup operation, and another filtering and validation rules. So ensuring that these transformations are applied correctly to yield accurate results is difficult. If the transformations are incorrect, it can lead to inaccurate or incomplete or misleading the data in the target database. How you can solve it? We can focus on comprehensive test cases for every transformation rule and logic. Also, by doing the regression testing and transformation logic validation testing is very crucial here. Apart from all these, there is also some changes in ETL testing like scheduling and automation, which means the testing process might delay the execution of ETL jobs or disrupt other critical operations. So, by using the automation tools, by implementing the parallel execution for testing to ensure the parallelly the other ETL process also runs smoothly without any delays. So, in this way, you can overcome the other challenges also. So, ETL testing without cloud services present these kind of challenges that arise due to limited scalability, flexibility, and more of manual processes. These challenges can affect the efficiency, reliability, and cost effectiveness of the ETL process. How you can overcome through the cloud? So first, for this, we need to know about EC2. EC2 is, yes, Elastic Compute Cloud. It's an infrastructure as a service. AWS offers this as an infrastructure as a service. There are quite other services like platform as a service, software as a service. EC2 is a part of infrastructure as a service. So it is simply a virtual server in Amazon Web Services. With an EC2 instance, AWS users can request and provision a computer server within the AWS cloud. They are created from AMI, which means Amazon Machine Images, which are templates that can be used to create multiple instances with same configuration settings. AM is nothing but a customization of an EC2 instance. So, what are the capabilities? So, renting virtual machines. It provides scalable virtual servers to run applications such as compute optimized, memory optimized, or storage optimized. EBS. EBS offers elastic block storage, offers persistence and high performance storage for EC2 instances. It works like a hard drive that can be attached to an instance, ensuring that the data persists even if the instance is stopped or terminated. Elastic load balancer. It distributes the load across machines, the traffic across multiple instances, improving reliability and performance. Auto scaling group. It adjusts the number of instances based on demand, like scaling up and scaling down, ensuring cost efficiency and availability. Together with these features, EC2 is a versatile and powerful tool for hosting applications and handling workloads efficiently and optimizing costs while ensuring the reliability. So, how you can bootstrap the EC2 instance? Bootstrapping means launching commands when a machine starts. So a set of actions, a set of commands will be written in the EC2 user data script, and this script is run only one when the instance is first time starting. So it is used to automate the booting tasks such as like installing the updates, installing the software, some common files like from the internet, downloading all those things can be defined in this EC2 user data script. So this script can run only with the root user access. And EC2 instance type, as I already mentioned, it is compute optimized. It is great for compute intensive tasks, means which require high processor, high performance. So memory optimized is like fast performance for workloads that process large data sets in memory. So use cases like non-relational databases, in-memory databases for BA, or the use cases for memory optimized EC2 instance. Storage optimized is also a kind of a memory optimized EC2 instance. It's great for storage intensive tasks that require high sequential read and write access to large data sets on local storage. And the storage optimized use cases are OLTP, relational databases, data warehousing applications, and distributed file systems. Also, EC2 instance type has the naming convention, like it starts with this kind of instance family and also the instance size. So what are the type of instance available in EC2? So it is like it is based on t-shirt sizes to represent the variations in computing power, memory, and resources. These sizes are designed to meet different workloads and use cases, like T series, like T2, T3, T3A, or for bustable performance instances. So in for this type of instance can be used for small applications, developments, web servers, and light databases. M series is like include M5 large, M5X large, M5 2X large, so on. It is good for applications that need balanced resources, including small and medium-sized databases, data processing, and enterprise applications. C series, it's a compute optimized instances like C5 large, C7 2x large, all these things. They provide more RAM per virtual CPU compared to general purpose instances. P series, it is a GPU instance for machine learning. Likewise, there are few other series. I series are storage optimized instances. X series are extreme memory instances. Z series for high performance compute instances. These instances size allow user to select the best configuration for their workload based on CPU, memory, storage needs, with the flexibility to scale up or down as per the requirement. And now you have the EC2 instance, and even if you have EC2 instance, you need your data to be secured, you need your process to be secured. For this EC2 instance to be secured, so for this we have security groups. So it is an important component for securing your EC2 instances. They allow you to control inbound and outbound traffic, ensuring that only authorized users and services can interact with your instances. By defining the right rules and following best practices like least privilege principle, you can enhance the security and management of your EC2 environment. So when you launch an EC2 instance, you must associate to one or more security groups with the instance. You can specify security groups during the instance creation process or modify them later. Each EC2 instance can belong to multiple security groups, and the rules from all associated security groups are combined and applied to an instance. Security group rules can be referenced by either IP or by security group name, and it can be attached to multiple instances. And the security group is locked down to a particular region or a VPC combination, which means virtual private cloud. And if it's good to maintain one separate security group for SSH access. And if your application is not accessible, then it's a security group issue. If your application gives a connection refused error, then it's an application error or it's not launched. All inbound traffic is blocked by default. All outbound traffic is authorized by default. So this is about the EC2 instance, how it is being secured using the security group. So now we have the EC2 instance. Now we know what are all the EC2 instance types available, EC2 t-shirt sizes, and EC2 compute optimized or memory optimized. So now you know what you want to configure. But with respect to budgeting, which purchasing option you can go for. So I will compare, this is a hotel resort. I will compare the buying of booking a room of hotel resort with respect to the EC2 option purchasing. So on demand, it is like coming and staying in the resort. Like whenever we like, we pay the full price. So like when you directly walk into your hotel resort and you are booking the room, so you will do that without any prior plan, which means it's for a short term, unexpected, right? So like that, on demand instances is for short time workload, and it is a predictable pricing, and you have to pay by second. So it is recommended for the short term uninterrupted workloads. The next is spot instances. So like the hotel allows people to bid for the empty rooms, and the highest bidder keeps the room, and you will be kicked out. Your bidding price is lesser than the other person. Same way, the spot instances, it's for short workloads, maybe a non-critical, not important workloads, you can go for spot instances. It is cheap, but it is less reliable. The consequences, it is less reliable. If someone is bidding for higher price, you will lose the instances. And the other good part is you can get a discount of up to 90%. So like you're planning ahead for going for a vacation, and you are booking the room for a long time for a vacation in a beach site, so you will get a good discount, right? The same way, reserving your instance like either for 1 or 3 years, and you can pay the for the instance either fully or partially upfront, or without any upfront, you can just reserve it. So it is recommended for steady state usage applications, and you can buy and sell this in the AWS marketplace, and you will get a discount of up to 72% for the reserved instance. And it is for longer workloads, and it also provides you the convertible option, which means you can modify the instances, which is kind of flexible instances. For that type of instance, you will get a discount of 66%. Also, it provides you a saving plan, like you are paying certain amount per hour in the hotel for a certain period, and you can stay in any room type. So in this case, you may get a savings plan, like the hotel gives you, you can pay an amount per, you pay amount per hour for certain period, like for 3 months or 1 year, like that, and stay in any room type whichever is available. This is called saving plan, like king suit or sea view, anything whichever is available, but you will pay per hour. This amount will be fixed and for certain period. So the same way, the savings plan AWS is offering, it is commitment to an amount of usage for longer workload, and you can get a discount of 72 percentage, and it is locked to a specific instance family. You cannot modify the instance configuration for the savings plan, and it is locked to a particular AWS region. You cannot use it on another AWS region. Dedicated host, like you are booking an entire building for the resort, for your company team integration, something like that, you are booking the entire building, right? The same way, dedicated host, you are booking an entire physical server and control the instance placement, and it's a most expensive option, like you should bring your own license. So for this, you go for dedicated host. Dedicated instance is nothing like the customers will not share your hardware, so for that you can go for dedicated instances. There is something called capacity reservations in the purchasing option, like how you book a room for a period with full price. Even if you don't stay in it, you are thinking that you will stay, but you are not sure about it, but you are booking for full price. The same way, you can reserve the capacity in a specific availability zone for any duration. It is suitable for short term and uninterrupted workloads. So now, based on your need, you can purchase the instances under these plans. Moving to the next slide. Yeah, it looks to be funny, but it carries a very heavy fact in this. So, like, when you are using the instances, it's okay, but when you are not using the instance, you have to terminate the instance. If you are not terminating the instance, obviously you are going to be billed. You may think you're closing the everything, but you have to manually terminate the instance once your task is completed. Or you can even define that in your user data script or the EMR cluster initiation script, like auto terminate polish by auto termination policy. Like if your task is completed, then the auto termination policy has to be initiated. Or if the instance is idle for this many hours or this many minutes, the instance has to be terminated. By this way, you can save money. Obviously, even if you go for any purchasing option, for a cheaper option also, AWS always charge you for pay as you go, pay for the usage you are doing. So for this, you have to terminate the EC2 instance once your task is completed. Maybe you can even check on the alerts or cost explorer. Sometimes you may forget to terminate, and you can see the bill why it is going beyond. Then you, by using the cost explorer option available in AWS, you can go and check which service is being charged high. Then you will get to know this instance is for this instance usage, it is charged high. Then you will get to know how many minutes has been used, even if you are not actively used it. So for this scenario, you have to terminate the EC2 instance even by defining auto termination policy. So moving to the next slide, S3. Yeah. So S3 is nothing but simple storage service. It has infinite scaling. Why S3 is a backbone? High availability and performance, ensuring fast content delivery worldwide. It has seamless integration with other AWS services, making it as an ideal choice for modern web applications. What are the use cases? It has backup, storage, disaster recovery, archive, hybrid cloud storage, and application hosting, media hosting like Netflix, deliver massive amounts of video content to its users globally, and data lakes, big data analytics, software delivery. Static website like Dropbox is built on S3 as its backend to store user files securely and reliably. And Instagram also uses S3 for the images and video backup. The Guardian is using the S3 for article backup. Also, Nasdaq stores 7 years of data into S3 Glacier. Cisco runs analytics on its data and gain business insights. Amazon S3 bucket has naming convention rules. It should not have any uppercase. It should not have any underscore. It should be between 3 to 63 characters long. It cannot be an IP. Something these kind of rules it has. So you should, when you are defining the S3 bucket, you have to follow these rules to keep the S3 bucket name. It cannot be starting with a lowercase letter or number. It cannot start with a particular prefix or particular suffix. And Amazon S3 allows people to store objects. Objects like objects means files here, in buckets. Buckets mean directory. So you can store files in the folders. So objects in the buckets. So Amazon S3 objects. So the S3 objects, the files have a key. The key is nothing but the full path, the location of the location path. So it is the key is composed of prefix plus object name, and there is no concept of directories within the buckets, which means folders within the folders. Just keys with very long names that contains slashes is the object key, and the slash is the separator to identify what is the object he placed here. And object values are the contents of the body, and the maximum object size is 5 TB, which means 5000 GB. If you're uploading more than 5 GB, you must use multi-part upload, like kind of Parquet file uploading. So in this way, you can upload the objects in the S3 bucket, and also you can enable the versioning. And when you are enable the versioning, the version ID will appear, so you can restore back to the previous version of the file using the version ID. Also, S3 allows people to store objects in the buckets. Amazon S3 security. Yes, when you are loading the data, you need the data to be secured, right? So even for that, you have to define the policies. So you need to do the encryption, and also IAM policies, bucket policies, and access control list. So object access control list, bucket access control list. Refer to object access control list is for securing the objects. Bucket access control list for securing the buckets, securing the data in the buckets. So they are legacy mechanisms used to manage access to S3 resources. IAM policies. So using bucket policies and IAM policies for modern access control, because they are more scalable and flexible, and it is easier to manage permissions across multiple users and services. It supports more advanced conditions like IP address restrictions and time-based access. So using the IAM policies for securing the S3 data is generally a recommended approach. Object access control list. They are permissions that are specifically applied to individual objects stored in an S3 bucket. So what is the purpose? To define who can access a particular object and the level of access they have. Permissions can be granted to specific AWS accounts and predefined groups, example for everyone or for particular roles. Access levels will include like granting the read access or write access. So use case I can say for object access control is public read access to the specific files in the website or the images in the website, while keeping other objects are private. Next one is bucket access control list. It defines access permission at the bucket level, affecting objects within the bucket. So what are all the objects under that bucket also will have the same security policy defined for that bucket using the BACL, bucket access control list. So it is used to specify who can perform operations on the bucket itself, example listing objects. And optionally, you can access objects within the bucket. So what are the key parameters like read access, write access, read ACP, who can view the access control policy of the bucket, who can modify, view, write ACP, who can view the who can modify the access control policy of the bucket. So these are all the parameters can be defined in the bucket access control policy. So predefined groups can also be assigned permissions such as authenticated users or for everyone. So the use case I can say is like granting a team to upload files to a specific bucket without needing any direct credentials. And what are the limitations for this ACLs? It's becoming challenging to manage for large scale systems with fine grained access requirement, and it offers less flexibility compared to the bucket policies and IAM rules. And it is generally recommended to use bucket policies along with IAM policies instead of ACL, because when you're going for larger applications and large data set, it's always recommended to use bucket policies along with IAM policies. And what are S3 bucket policies? S3 bucket policies is based on JSON. It's a JSON based policies. It has the parameters like resources, effect, action, and principal. Resources means which are all the resources are need to be secured. Buckets and objects. What is the effect? It has allow rule, allow or deny rule. Action, set of API to allow or deny. And principal, which account or user this policy needs to be applied. So this is about the JSON based policies for S3. So how you can grant the rule, grant public, either you want to grant public access to the bucket, or by forcing objects to be encrypted during the uploading, or granting access to the another account. So these are all some of the S3 bucket policies you can define. Going to the next. Yes. So storing data on the disk, either it is elastic file system, EFS, or elastic block storage, or EC2 instance store, or S3. So it can have its limits. In this case, you can opt for databases offered by AWS. Sometimes we may want to store data in an organized, structured way to build the indexes for efficiently querying and searching through the data. And also we need to define relationships between our data sets, right? In this way, in this scenario, we can go for the databases offered by AWS. So what is What are the databases and shared responsibility in AWS? So AWS is the responsibility for the security of the cloud, like infrastructure management, to ensure the physical security of the data centers and the operation of managed services like Amazon RDS and DynamoDB, and also for patching and maintenance. These are all the AWS responsibilities. What are the customer responsibility like AWS uses for us? For security in the cloud, including the data protection, access control policy, what we are defining, application and security. So how you can implement it? By implementing this encryption, access control, backup, by ensuring the compliances is properly followed or not, by configuring the database instance correctly with all the scaling policies and ECT security groups. In this way you can take care of your data in the AWS. So it is AWS uses our customer responsibilities. What are the best practice we can follow? By using the identity access management, by defining the IAM policies. So what are the databases offered by AWS? Non-relational databases are like NoSQL databases. It is to build for specific data models and have flexible schemas for building modern applications like search databases or key value. AWS relational databases are like AWS RDS. It is a managed DB service using SQL as a query language. What are the advantage of using RDS over the database on EC2? It has automated provisioning, OS patching, and continuous backups, and restore to a specific timestamp. Like point in time restore can be done. You can do monitoring the dashboards. The read replicas are there for improve the read performance, and you can set up in multiple availability zone for disaster recovery. And maintenance windows will be there for upgrades, and the scaling capability like vertical scaling by increasing the size of the instance, horizontal scaling by increasing the number of instance. All these are like taken care by RDS, and storage is also backed by EBS. And apart from that, Amazon Aurora is also one of the database offered by AWS. It is a proprietary technology from AWS. It is not an open sourced one. PostgreSQL and MySQL are both supported as Aurora DB, and it is AWS cloud optimized, and it claims 5 times performance improvement over MySQL on RDS. And it is storage automatically grows in increments of 10 GB up to 128 TB. It costs, of course, more than RDS, like 20% more, but it's more efficient. And RDS read replicas. So you can scale the read workload of your DB. You can create up to 5 read replicas. Here we have 3 read replicas, and it is taken care by ASG, auto scaling group, and the elastic load balancer automatically balance the data load. So the read request, not the data load, automatically balance the read request to the different EC2 instances, so that the application will not be giving high latency, and then the database will be giving back the answers to the EC2 instance through, and again the through elastic load balancer, the answer will be given back to the end users. So data, the read request, it will be from multiple EC2 instances, but the write request will be only one write request to, and it will be always written to the main GB. So it can be happen only through elastic load balancing and auto scaling groups. So in this way, the application latency will be very much less, and the performance will be very much improved, and the business obviously will be improved. Multi availability zone. So how we are able to handle when in case of failover, like some outage in AWS in a particular region, or some application crash, or some DR. How we can handle it? By setting up an failover DB across another availability zone, not in the same availability zone. In this case, the application when look for a, when the application when gives a request to the DB, and this DB is like not accessible, then obviously the request will be transferred to the failover DB. From this DB, the answer will be returned back to the application. In this way, the outage will be handled without any business discontinuity. So it can have only one other availability zone as failover DB, not on multiple availability zone. In this way, because the request will not know that to which availability zone the request has to be transferred. So it is always best to have only one availability zone as a failover DB, and it cannot be in the same availability zone where the main DB resides. And DynamoDB, it is not a relational database. It scales to massive workloads, and it's a serverless database. It can handle millions of requests per second, like trillions of rows, and it is low cost, and auto scaling capabilities are there, and it is recommended to use for standard and infrequent access. Redshift is also offered by AWS, and it is not used for OLTP, it is for OLAP. And the data is loaded once every hour, not every second, and it has 10 times better performance than other data warehouses. And it is columnar storage of data, not a row based, and it has massive parallel query execution, and it has a SQL interface, and you can pay as you go for the instance provision using this instances provision using this Redshift. And BI tools like AWS QuickSight and Tableau are like by default integrated with the Redshift. Amazon QuickSight, it's also a serverless machine learning powered business intelligence service to create interactive dashboards. AWS Glue. AWS Glue is mainly for ETL process, like to manage the ETL service and to prepare and transform the data for analytics. And it is fully a serverless service, and it has catalog of data sets, and it can be used by Athena, Redshift, and EMR. And DMS is also another service offered by AWS. It's a database migration service. You can quickly and securely migrate your databases, and the source database remains available during the migration. It's not like it won't be accessible even during the migration. The source database will be remains accessible, and it supports both homogeneous, which means between the same type of databases, like one Oracle database to other Oracle database, or the heterogeneous migration from Oracle database to Microsoft SQL Server. It supports both homogeneous and heterogeneous migration. Amazon QLDB, Quantum Ledger Database, and Neptune is also another database services offered by AWS. These are all about the database offered by AWS, where you can use it for ETL as well as the ETL testing. Move to the next, EMR. EMR is Elastic Map Reduced. It is just a service built on top of EC2 to make things like distributed map reduced jobs easier to perform. It is one of the AWS cloud computing services for swiftly processing and analyzing large chunks of data. It includes comprehensive data technologies like Apache Hadoop, Apache Spark out of the box, and it is ready to use with EC2 and S3. And it is not a DB, but it integrated with the Hadoop cluster for analyzing big data on AWS. And it is a big data framework, and it simplifies the creation, management, and scaling of Hadoop clusters for analyzing and processing the vast amount of data. It quickly helps to handle large scale data processing, and it consists of hundreds of EC2 instances, offering scalability and flexibility. And it support advanced tool like Apache Spark for distributed data processing and machine learning. HBase is for non-relational database that works on top of Hadoop. Presto for fast querying of large data sets. Apache Flink for real-time data stream processing. And it also handles provisioning and configuration of clusters, reducing operational overhead. It automates tasks like monitoring, logging, and cluster termination after job completion. Yes, you can terminate the cluster in the EMR cluster initiation script itself, as I mentioned earlier about the terminating the EC2 instance. And it is also take care of cost efficiency and auto scaling to adjust resource based on workload demands. And the spot instances can be integrated with this EMR, and it can save up to 90% of the instance cost. What are the use case you can do? The batch processing of large data sets in the ETL workflows, and training models using distributed computing frameworks like Spark in the machine learning side, where in the web indexing you can use the crawling and indexing large volumes of web data, and big data analytics for processing logs and streaming the data and business intelligence data. These are the use cases of EMR. It also provides a scalable, cost efficient, and easy to use solution for handling big data analytics by leveraging tools like Hadoop, Spark, and others. And you can focus on insights and innovation without worrying about the infrastructure complexities. Move to the next slide. Yeah, what is the part of AWS in ETL? So with this diagram, I'm going to give a detailed explanation on the flow. So the diagram represents typically an ETL process and the ETL pipeline using AWS Glue. This architecture is designed to streamline the process of extracting data from sources and transformation it as needed and loading it into the target systems. So the data stores. The process begins with data stores. These could be like various types of sources such as relational databases, NoSQL databases, data lakes, or other storage systems. And AWS Glue crawler scans these data to discover and extract metadata. What is metadata? The data about the data, which means the data types of the data data in the data stores, what are all the data types, what are the constraints defined like keys and the table structures, columnar, what are the attributes, what how many number of columns, how many fields are present. All these are metadata. The data about the data is metadata. So the crawler scans these data stores to discover and extract the metadata. And crawler and data catalog, it automatically identifies the schema like as I mentioned, table definitions and the other metadata of your data. It saves this information into the AWS data catalog, and it acts as a central repository for all metadata, making it easier and manage the discover the data sets. Step 3 is management console. It serves as the control panel, entire control panel, where the users can set up and manage jobs, schedule crawlers or ETL jobs. It monitors and troubleshoot the entire workflow. It provides a user-friendly way to manage workflows without any deep technical expertise. So how you can schedule it? Jobs can be initiated through a schedule, like with a specific interval, or triggered by an event like when the new data is arrived or when the new data is deleted, when any existing data is deleted, like this kind of event occurs, then the job will be triggered. This automation minimizes the manual intervention and ensures the pipeline runs efficiently. Now comes to the full entire ETL process. So data is pulled from the data source, and the raw data may be in the various format or structures, and it is performed, and the transformation will be performed using the script, typically written in Python or Scala with Apache Spark. The transformation already mentioned, like including the cleansing of data, like removing duplicates, making the data formatted, missing handling the missing values, and using making the data enriched and formatting as per the business requirement. Then the transformed data is returned to the data target, such as data warehouse for analytics platform. The data target is where the cleaned data, processed data is present, and it will be used by the data analyst for reporting, and machine learning models for predictions or dashboards or any other analytics tools. So what are the key components that needs to be taken care here? You have to know about crawler. It automates the metadata discovery. Data catalog, it simplifies data organization and searchability. Transformation script, it enables flexible and scalable data transformation. Scheduling events, optimize the ETL process, automates and optimize the ETL process. What are the benefits of this architecture? Scalability, it is designed to handle the large scale data processing, and it reduces manual effort with triggers and schedules like doing the automation, and it supports various AWS services and external systems, and metadata management like centralized through the Glue data catalog. So it is the entire life cycle of the ETL process using the AWS Glue, from extracting raw data to loading the transformed data into the target system. The automation and serverless nature of AWS Glue make it a powerful solution for building scalable, reliable, and cost-effective data pipelines. Moving to the next case study. Yeah. So here we are creating this shows a initiation script, the EMR cluster script. So how you are creating the cluster? So I'm creating the cluster here. I'm defining what are all the applications I need and the cost center. This is with respect to budgeting. So you can this with this ID you can get to know once the cluster is initiated, once the service is started, you'll get to know how much it is billed for this service. And organization you can mention here, and the instance profile name, and what are all the instance group like instance count, EBS, elastic block storage configuration, how much volume, how much size you need, all the instance group configuration, how many master nodes you need, what is the t-shirt type and size you need, and what are the properties and what are the classifications, which kind of application you need. Again, I'm giving the worker nodes as 5 work nodes. And why I'm going for bid price? Because since it's not a critical job, I'm using only for the sample test execution. I'm going for the spot instance. That is why I'm giving the bid price here. And EBS configuration. And again, the work nodes, this is main node, primary node, master node. You can say either master node or primary node instance type. This is the core node, which is a worker node instance type. All these you are defining it here. And I also want PySpark Python to be installed along with the EMR cluster, which means to be used along with the EMR cluster. And I'm giving the bootstrap script here. I already created the bootstrap shell script. So I'm using the bootstrap shell script to be initiated along with the EMR cluster initiation. So I'm giving the path here. So it will access from this path and it takes the script, and it what are all the actions, like set of softwares to be installed during the initiation of the EMR cluster will be executed here. And also I'm giving the scale down behavior, like I'll not have, since it's a sample test data execution, I don't want to scale up, I need to scale down to reduce my billing. And also after task completion, the EC2 instance needs to be terminated. So this also I'm defining it here. And I'm going to show the automated test execution using the AWS services in the next. So here, once you are initiating the cluster, this kind of screen you will be seeing. So you will be initiating that script by logging into the AWS console from PowerShell. So through the PowerShell, you will be logging in and you will be executing that script. Then you will be seeing that EC2 instance is initiated and the EMR cluster is created. And here, this is an example of S3 bucket. So here, this is the bucket name, and these are all the objects, and the objects are, as I mentioned earlier, will be identified with the slash separator. And also when it is more than 5 GB, it should be loaded as a multiple part file. So this is an entire file, but it is loaded as a multiple part. It's called a packet files. And also this is .dat files, to show any type of file format can be handled in the S3, and it can be used for testing using the PySpark. So it is any type of file format can be combined as a table, and you can use it for your test execution. And if any type of file format can be easily registered into a temp table, that kind of feature the PySpark has. So this all can be done through this service EC2 instance and the EMR service offered by the AWS. So next slide will be, I'll be showing the automated test execution. So this is the AWS console. I'm logging into the account. I'm selecting the role here. I'm going to the Swati FCQA role, and this is the region which I'm working in. So in this region, I'll be having selected services for this role. And these are all my recently visited services. These are all of the services offered by AWS. And what are all the databases, as I explained, offered by AWS. Now I'm going to show the EMR cluster. So I'll be checking. I have showed already the EMR cluster script. So once I initiate it in the console logged in from the PowerShell, in this screen you will get to know whether the cluster is initiated or not. So here I'm checking it is initiated, and the status isn't ready. So I'll be going through what are all the properties. So this is the cluster ID you can identify, and one primary node, which is master node, and 17 core nodes. What are all the applications I have configured in my script, I want to configure in my script, that are all being configured here. And this is the IP ID. With the IP address, you can use your EMR cluster, and this is the S3 location where it will collect the EMR logs. So if anything happens, all these will be all the events, all the details will be captured in the EMR logs. You can go and check if suppose failing or if it is ready, all will be captured in this S3 location. And you can even manually terminate the cluster. And what are all the bootstrap actions here? I mentioned in the script, the same it is mentioned here. Whatever I mentioned in the script, that is being executed here, and you can see it as a proof. Say install packages. And what are all the instances I have defined? Primary node and worker node. I'm going for on-demand and spot instances. So it's R4, 2 times large. This is the instance type. How many volumes I have defined? The same volumes I'm getting here. What is the EBS size? How many worker nodes? These are all of spot instances. So how many volumes, and what are all the IP address it carries, the DNS. Now I'm going to the applications. What are all the applications that I have configured, I wanted to use. Ganglia, Spark, PySpark, Python, the same the instance group worker nodes. Along all these worker nodes, these applications will be integrated. To check that, you can check it here. And monitoring using CloudWatch metrics, the cluster status, whether it is started, initiated, or it is failed, everything you will get to know here under this tab. The event is the cluster state change, the high level, like whether it is available or not. And here this is the cost center I have given. Under the same cost center, this in service is initiated. So with this ID, you can get to know how much it is being billed. It will come under the AWS budget and organization module. So now I'm going to log in to AWS console from PowerShell. Previously, I have already logged in and I have initiated the cluster and the cluster is ready. Now I'm going to use that cluster. Not directly, but indirectly using for my test execution automation. So I'm logging into sudo user so that I can perform access all the buckets. So before I do the test execution automation, I want you to know that I am going to create a sample test suite. So why test suite? Because the snippet which we have created, Python snippet which we have created, will be expecting these parameters from the input file. So it will expect the input file to be load for to run the code. So the what are all the parameters, what are all the arguments it will expect. So all these execute flag, uh, requirements, test set, test case name, test description, all these test type, step description, source query, target query, all these parameters will be defined in my code snippet. So in our code snippet, it will expect all these parameters to be passed from the input file. And why I have kept some and all blank, because the mandatory parameters are source query, target query, all these are the mandatory parameters. It cannot be blank. The remaining can be blank, it's optional. So which is I have already defined in my snippet. So this is the sample test suite. So why test suite? So in case of doing the repeated test cycles or the same, instead of, like if there is some feature is added into some module but it is not directly impacting your data, but still you want to run one more round of testing, in this case to save time you can go for this test automation. So now I'm uploading the test suite in the S3 bucket. So I'm uploading my test suite, which is an input file in the S3 bucket, and I'm securing my data by defining the encryption key here. All those things I'm giving an option. I'm selecting the encryption key just to secure my data, even if it is in S3. So I have uploaded it now. Now this is my, so now I'm copying it from the S3 this folder to my testing automation folder. Why? Because under the same folder I have kept my Python snippet. So I want my input file also to be downloaded in this folder so that the script can read the input file under the same location. So now I am going to run my code. I am going into this folder. So this is the Athena framework version 2. This is my snippet name. This is my snippet which I'm going to use. This is the input file. So what is there in the snippet? I'll just give a quick run through in the snippet. This is this. These are the set of scripts which we have written. So it will expect all the input parameters. So it will say generate the report also, what will the output, the test evidence, all these things, test case, pass, fail, how many tests executed, how many tests is not executed. So all these will be automated using this script. And what will be the output? Output is or the files will be generated, like the test evidence, test summaries, or some of the files will be generated as a output, and we can directly use that as a test report. So you can see test evidence path, all those output files again will be generated in the S3, and the S3 location also will be defined in the Python script, this snippet. So I'm going to run this. I'm triggering this command. Okay, it started executing. So if there is any issue or anything, the script, if there is input file is not proper, or the script needs to be updated, then it will not be executed completely. It will be like corrupted. It will be like the task will be incomplete. You will get an error notification. So in this case, what you can do, I'll show you in the upcoming recording. So here, I'm just showing you. I have showed you what are all written in the script, right? Now I'm showing you where my Python script is present. So under again in the S3, I have kept all my Python script. So under the same S3, through EMR, I'm running this script with the input file which is already uploaded in the S3. So I don't have any local software setup needed. I don't need also. Just with the use of AWS, I'm doing my complete test execution and also automating it. So whatever is being printed and populated in the output and also in the log file, this will be like populated in the screen as well, so that you will get to know what is happening, whether it is running successfully or not. So in test evidences path, that is also will be populated here. So what are all the output files will be populated. Their path will be populated here. Now the test execution is completed, and you can get the overall status here as well, rather going and checking in the report. So now you can see the run ID. With this run ID, you can go and find your S3 file, output file, that which is the test report file. So under this location, under this run ID, the file will be available. So what is the run ID here? It ends with 6F4. So it is 6F4. I'm reconfirming it again, and I'm going. It is 6F4. So you can see whatever the test suite you have given, underscore evidence will be added. So I have given in the script like the input file name along with the underscore evidence. You can find that as an output file. And test execution summary, it's a high level summary, and test execution log. So I said when there is the task is not completed, the execution is in the middle, it is not incomplete, it got closed, all these details will be captured in the execution log. Even if it is success also, the execution is success also, it will be captured in the execution log, so that you can go and see. Sometimes the people who was not aware of not giving the mandatory parameters, they will get to know when they go and see the log that this field is empty, expecting an input. And if there is a different file format is given, then you need to update your Python script, so you can get, it's like kind of simply a debugger. You can go and see the log file which is also generated as part of the script. the customized script which we have created. So I'm opening all the output files generated here. So this is the evidence. So now you can see the among three test cases, two test cases are passed, one is failed. So overall the test execution is failed. So which is the test case? You can go and see the high level summary. This is a detailed for the entire test suite. It will show the pass or fail everything. Even if you have 100 number of test cases, it will show which test cases pass, which test cases fail. The summary will tell you like among three test cases, two test cases passed, one is fail, and the overall status is fail. And you will also get to know the IDs here. So if there is like among 100 test cases, what all the test IDs get failed, you can identify from here. Here it shows the test which is failed. So with this, you can go and debug in your test evidence report which test case got failed. So in this test case, this got failed. Validate the data structure. So this got failed. So you can then again you can individually go and debug in by logging into a PowerShell using the PySpark query. So this is about the case study of test execution automation. So when we need to use it, you need to use it in case of repeated cycles of same test, or if when you need to use it if there is like a large number of test cases, like individually you are taking and executing, and it will be a time consuming one. Rather prepare the test suite and run the complete automation suite. It will give you a proper output file. So this saves your time, and also the output will be properly generated. Also it is customizable. So moving to the next slide. Yeah. So that brings us to the end of today's session. Feel free to send in your questions in the chat box. I'll address them now. Hi, I'm just seeing the chat box. Thank you. So the questions, yes, you will have the recording. Everything will be recorded. Recorded video. You will have it in your email maybe in the next few days. Can we define our own EMIs, or can we? Yes, you can define your own EMIs. Uh, like kind of how you can define it, uh, by creating your configuration. You can define your own EMIs in a scenario what like it provides popular operating systems like Amazon Linux or Ubuntu Windows or Red Hat. These are useful if you don't need extensive customization. But if you are creating your own EMI, you can use it by launching your EC2 instance, providing you with full control of configuration and software installed. But the pricing is like you have to pay for the use. Most AMIs in the AWS marketplace will be a pay as you go model. So where you can charge, it will be charged based on hourly usage. But if you are defining your own EMIs, then it will be like based on the configurations used. It will be charged by the AWS. Also, an additional note: there are some free AMIs available in the AWS market space, so you can use it with no additional cost. But underlying EC2 instance, whatever is it is using, for that alone, you need to pay for it. So pre-configured AMIs can save you time in and effort in setting up the environments, and they are like easy to use. Many commercial applications and enterprise solutions like using the AWS marketplace only for taking using the EMIs. So it is easy and integrate with your AWS infrastructure, and also it has compliance and security. So it comes with certifications like security patches also, so that it complies with industry standards. Yes, so in either way it is you can do it. But the free EMS, as I said, for the EC2 instance, you need to pay it. And okay, so that's all for today's session. Thank you so much for attending and taking the time. As a quick reminder again, you will receive an email in the coming days with a link to the webinar recording, so you can revisit at your convenience. We truly appreciate your time and hope to see you again in our upcoming sessions. Take care and see you soon.
Millennium. IT for people. People for IT.